Yes. So continue from the last class, substitution versus elimination reactions. So very important student, the SN1 reaction and SN2 reaction and E1 reaction and E2 reaction. A slight introduction of this one. So unimolecular nucleophilic substitution reaction, that is that SN1 reaction. So tertiary alkyl halides or tertiary alcohols or tertiary alkyl ethers undergoes SN1 reaction because a carbocation is a more stable intermediate. So whereas the so it is a non-concerted reaction, that's why SN1 reaction is a non-concerted reaction. So intermediate is a carbocation is intermediate, so that so rate of SN1 reaction is directly proportional to the stability of carbocation. So if it is a chiral carbon containing a tertiary substrate, so if it is SN1 reaction, so a racemic product is the racemic product is the racemic product is the product. So that means that a 50% retention product and 50% inversion configuration will be there. So for and third one, if a substrate configuration and product configuration are the same, then that configuration is called a retention product. If substrate configuration and product configuration is opposite, for example S configuration become R configuration or R configuration become S configuration, this is the product considered as the inversion product. So racemic, what is mean by a racemic mixture is that is nothing but is optically inactive. So racemic mixture is optically inactive, so nothing but so because of the total optical rotation is 0. So if carbocation stability is increases, the very important, if carbocation stability is increases, the rate of racemization also increases. Carbocation, so once the carbocation is forming, there is a possibility of a rearrangement. So once the a preferable wherever the more stable carbocation is a favorable, so that in SN1 reaction particularly, so there is a rearrangement also possible. So that's why so a nucleophilic substitution is not only depend on the nucleophilic nature and also the substrate alkyl halide also the factor is influencing. So continuing of my class is that so the whether it is a substitution or elimination reaction, it's a depends on a nucleophilic character and basicity of the incoming reagent and the substrate, whether it is a primary alkyl halide or secondary alkyl halide or alcohol or ether. So that is the these are the factors, so they decides the substitution or elimination or reaction. So continuing, for example, here following transformation, you can see that so now because of you can see here this is the 1 methyl, yes, so 2 methyl 1 bromocyclohexane in presence of sodium ethoxide and ethyl alcohol, and so because of it is a cyclic system, so we won't think that because the trans elimination is the preferable, so that you can see this is the product. So this is the product because axial route anti-elimination, so because of anti-elimination the product is this favorable. And in presence of this one you can see that the 1 methyl cyclohexanol in presence of a concentrated sulfuric acid, and it gives the 1 methyl cyclohexane more substituted alkene. And similarly, for example, you can see here 2, 2 dimethyl cyclohexanol in presence of a acidic medium, and there is a elimination of water molecule and a loose water molecule, and it will form a carbocation. And you can see here because of this methyl 1, 2 methyl shift is there, and so now the secondary carbocation is become a tertiary carbocation, so that there is a loose, it loses one proton, so that the more substituted alkene is the product. Then another one, can see here 1, 2, 3, 4, 5 and 2 methyl and 2 iodopentane in presence of ethyl alcohol and under thermal condition, so the product is alkene. Both substituted, even though the, so not only even this OC2H5, so you can see here the substituted product also, there is a possibility, but more majority of product because thermal heating, so elimination reaction is the expected. So because of, so if it is a tertiary alkyl halide ones, you can see that 1, 2, 3, 4, 5 and 2 methyl 2 iodo pentane reaction with a strong base and ethyl alcohol is a solvent, and the product is that elimination product. So 1, 2, 3, 4, 5. So 2 methyl and 2 pentene is the product, and so this is the E1. It follows the E1 mechanism because it acts as a strong base. And look at here. So look at here, and this is the another class of example, and now this is the alcohol. So 1, 2, 3, 4, 5 and 3 methyl to 2, 3 dimethyl and 3 pentanol reaction with HBr. So it will the OH group is replaced with the Br. So now this is also it's a racemic mixture because it is a chiral center is there. So because of carbocation is the tertiary carbocation, so that sp2 hybridization and planar geometry, so that the racemic product is expected. So here the following questions, please tell me the answer. So identify the reagents you so what are the reagents can be used to achieve the following transformations. So for example, you can see that tosylate is there, alkoxide tosylate reaction with water, so it produces alcohol. And second example is that it is a primary alcohol 1, 2, 3. So propanol reaction with tosyl chloride in presence of a pyridine as a base, so reaction with sodium cyanide, and very simple conversion, so it is a SN2 reaction, so that alkoxide tosylate is converted into cyanide, so it is a SN2 process. And another one, you can see that this is the 2, 2 dimethyl 1 butanol is a reaction with HBr, so it follows the SN1 reaction. So just OH is replaced with Br, so it is a it is a substitution reaction. And another one, you can see that this is the chiral compound reaction with sodium hydrogen sulfide, and now the now the nucleophile is, so HS minus is a nucleophile, so the chlorine is replaced with thiol, so now it is also a SN2 type of reaction. And another very interesting example, for example, S configuration with 1 bromo 1, 2 diphenyl ethane, a reaction with a sodium ethoxide is a strong base, so elimination reaction, so major a trans stilbene, so this is called a trans stilbene. So ethylene substituted with 2 phenyl rings is called trans stilbene. And yes, you can see here because it is a tertiary alkyl halide, and there is a you can see that conjugation is there in presence of a solvolysis, so now substituted product also. So in solvolysis there is a possibility of substitution as well as elimination product, but major substitution product is the expected because of the more stable carbocation intermediate is there. And similarly, for example, 4 tertiary butyl 1 chlorocyclohexane reaction with sodium ethoxide, and the product is that 4 tertiary butyl cyclohexane is the a product. So now the question is that substitution or elimination, so what is the expected product. Now the same reaction, for example, the chiral carbon chiral centered halo, so chloro 2 butane is there, a reaction with a bulky base, so potassium tertiary butoxide via E2 elimination. So once we are using E2 bulky base, so 1 butane is a major product because of one product. And second conversion, for example, 1 chlorobutane reaction with sodium hydroxide and follows SN2 reaction produces one butanol product. So one butanol. And similarly, for example, the same product 2-bromobutane reaction with sodium ethoxide, because the major product stage of product, so 2-butene is the major product. And similarly, so same, for example, you can see that, yeah, so now so 2-bromo 2-methyl-butane reaction with sodium ethoxide, the product is that more substituted stage of product is the major product. And you can see here 2-bromo, you can see that yeah, 1-bromo 1-phenyl and butane we are taking here, and in place of a sodium ethoxide, and trans product and more substituted product is the major product. And similarly, you can see because of potassium tertiary butoxide, and so that because here there is no other, so only one beta hydrogen is there and it can eliminate, so it can form a, so like this, a product. So these are the very important example. And another one, so predict the major product for the each of the following. So for example, here chlorine is there and the reaction with the sodium thiol, so it is a weak weak base, but it is a strong nucleophile, so it follows SN2 reaction, that chlorine is substituted with the SH. And similarly, for example, now the 1-bromobutane reaction with the DBN as a strong base but weak nucleophile, so that it is elimination product. And so now it is a 1-methyl 1-bromocyclohexane, so water under thermal condition there is a, so substitution as well as both the products, even the sometimes, so elimination product also, cyclohexene also, it is a product is expected. Yeah, so because iodine is a very good living group, so that easily it can go the eliminated product. So once we are using a base, so instead of substitution reaction, 1-methyl cyclohexane is the product. And you can see iodine is there, and once even it is a secondary iodine is there, but because of tertiary butoxide, Hoffman product is the major product. So Hoffman product. So here 2-methyl 2-bromopentane, but by using of sodium ethoxide and in presence of a methyl alcohol, so more substituted alkene is the major product, so 2-methyl 2-pentene is the major product. So similarly, for example, 2-bromopentane reaction with sodium cyanide in presence of a DMSO, so now the Br is replaced with Cn, so it is a SN2 reaction. And similarly, same reaction can be 2-methyl 2-hexene, the product is a stage of product. And another interesting, you can see that ester is there, so the cleavage of ester by using of lithium iodide in presence of a dimethyl formamide as a base. So now the I minus is very good, very strong nucleophile, so that it is a backside. So now the ester cleavage will takes place, and tertiary butyl, so lithium carboxylate and methyl iodide is the product. And even so this is the, and even by using of a strong base, there is a possibility of SN2 formation of epoxide. So sodium iodide, and because of in ethyl alcohol there is a halogen exchange reaction also, it is possible. So once it is having a tertiary butyl oxy group and tosylate, but in presence of a HBr or whatever it may be the reagent HBr, so because tertiary carbocation is more stable, so the expected product is that so 1-methyl 1-bromopropane is the more. So another one, so this is a cyclic product in presence of ethyl alcohol and heating condition. So there is a 3 kinds of products can be, because rearrangement product, and here conform carbocation, so that it can give the different products. Another one, so this is called alpha and beta naphthol. So beta naphthol reaction sodium hydroxide, it can form a sodium naphthalate, and this one reaction with SN2 reaction iodobutane, so O alkylation. So this is called O alkylated product. So O alkylation product are expected. So another we can see here some more examples. So alkyl tosylate reaction with dioxane. So in place of a water medium, now water is the nucleophile, so SN2 reaction. So now it is the SN2 product. So now one, two, three, four, 5. So the product is that, for example, it is a 1, 2, 3. So it is a R configuration, but the product is that S configuration. And chlorocyclopropane with sodium hydroxide, so no product, because it is a ring strain will be there, we won't get so mixture of products. So because of this reaction with magnesium, so cyclopropyl magnesium bromide, and similarly, so it can react with tertiary butyl oxy, so that, so finally we will get this product. So these are the examples of so whether it follows Markovnikov and anti-Markovnikov products.